Archean, oceans, continents, in the first breath of life, 4.0 to 2.5 billion years ago. As Earth cooled further, the first fragments of continental crust emerged from the oceans. These early land masses were small, unstable, and volcanic, but they were the beginnings of future continents. Deep within the oceans, shielded from ultraviolet radiation, life made its first appearance. These were simple, single-celled organisms, ancient microbes that fed on chemicals and sunlight. Their existence marked a turning point in planetary history. Stromatolites, layered structures built by colonies of bacteria, still exist today as living fossils, silent witnesses of Earth's early biology. The atmosphere was still oxygen-free, but the first biological processes had begun to shape the environment. Proterozoic, the oxygen transformation and early life's evolution, 2.5 billion, 541 million years ago. The microbial world continued evolving. Over millions of years, photosynthetic organisms pumped oxygen into Earth's oceans and atmosphere. This triggered the Great Oxidation Event, one of the most dramatic transformations in planetary history. Oxygen, toxic to many early species, caused massive extinctions, but also opened the door for more complex life. Continents collided to form enormous supercontinents like Nuna and Rodinia. Ice ages swept across Earth, turning much of the planet into a frozen wilderness. Yet even in these harsh conditions, early multicellular organisms began to emerge. Red algae, soft-bodied creatures, and the first simple animals appeared. Small steps that would eventually lead to an explosion of life. Phanerozoic, the age of visible life, 541 million years ago. Today, this era contains everything we recognize as the natural world. Oceans full of creatures, forests, dinosaurs, mammals, and humans. Life diversified in extraordinary ways, surviving multiple mass extinctions and global catastrophes. Paleozoic, the rise of ecosystems, 541 to 252 million years ago. The Cambrian explosion unleashed a spectacular variety of life in the oceans. Animals with eyes, shells, claws, and complex body plans appeared within a relatively short time. In the Ordovician, coral reefs and fish flourished. The first mass extinction struck at the end of this period, caused by a sudden ice age. During the Silurian, life took its first steps onto land. Simple plants rooted themselves in damp soils, followed by early arthropods that crawled across newly formed coastlines. The Devonian seas were dominated by powerful fish, some with armored plates and fearsome jaws. The first forests began to grow, and early amphibians emerged from the water, beginning the conquest of land. The Carboniferous was a world of towering trees and swampy forests. Oxygen levels soared, enabling insects to grow to gigantic sizes, dragonflies with wingspans as large as hawks. In the Permian, reptile-like mammal ancestors appeared, but this era ended in disaster, the largest mass extinction in Earth's history. Over 90% of species vanished, marking a profound reset. Mesozoic, the age of dinosaurs, 252 to 66 million years ago. Life rebounded. The Triassic saw the rise of the first dinosaurs and small early mammals. During the Jurassic, dinosaurs reached colossal sizes. Sauropods grazed on vast forests, while predators like Allosaurus ruled the land. The first birds took flight. The Cretaceous brought even greater diversity. Tyrannosaurus rex, Triceratops, and Velociraptor dominated ecosystems. Flowering plants evolved, transforming habitats. But this era ended abruptly when a massive asteroid struck Earth, triggering global fires, darkness, and the extinction of the dinosaurs. Cenozoic, the age of mammals and humans, 66 million years ago, today. With the dinosaurs gone, mammals flourished. Whales returned to the sea. Primates diversified. Grasslands spread across continents. By the Neogene, early human ancestors appeared in Africa, adapting to shifting climates and landscapes. In the Quaternary, ice ages came and went. Humans evolved, migrated, and eventually colonized every corner of the planet. Through ingenuity and adaptation, Homo sapiens became the dominant species, capable of shaping ecosystems and altering the planet itself. Conclusion. From molten beginnings to ice ages, from towering dinosaurs to modern humans, Earth's journey is a story of survival, devastation, and renewal. Each era left its mark, carving the path that leads to the world we live in today. This is the grand chronicle of our planet, a history written in stone, in fossils, and in the very air we breathe. And now, at the end of this long journey, the stage belongs to us. Every great event in Earth's history reminds us how fragile life can be, yet how incredibly resilient it truly is. When we look up at the sky, we share the same view ancient creatures once lived beneath. Their footprints may have vanished, but the legacy they left behind still echoes around us. Remember, history is not only meant to teach us about the past, but to guide us toward the future. Earth's story is far from over, and the next chapter will be written by you. If this adventure inspired you, remember to subscribe so you can join us in the discoveries yet to come. Your comments help shape the stories we explore together. And every like you leave allows this journey to reach even more curious minds. Until we meet again in the next chapter, never lose your sense of wonder.